Okay, so we spoke a little bit about ATP production. We spoke about you have glucose that gets broken down into pyruvic acid. That's called glycolysis. That takes place in the cytosol, but the Krebs cycle and the electron transport chain take place in the mitochondria. We want to make sure oxygen is available for pyruvic acid to enter. But if you're exercising and you're out of breath, you have no energy, then pyruvic acid is converted to lactic acid, which is another sugar. That goes into blood. It doesn't go into the mitochondria for ATP production. It's just you're exhausted, you're tired, you need a pause. Pyruvic acid gets converted to lactic acid. It goes into the blood. When it goes into the blood, that lactic acid can actually enter what is called the Cori cycle, where your glucose was broken down into pyruvic acid or pyruvate. That was called glycolysis, but you are now out of breath. You have no energy. So pyruvate goes to lactic acid, goes into the blood, goes into the liver. Lactic acid is converted back to pyruvate in the liver, back into glucose. Okay? When you break down glucose, we call it glycolysis or glycolysis. And when you're making new glucose, it's called gluconeogenesis. We're making new sugar. When you have available oxygen, now pyruvic acid can enter the mitochondria. Fatty acids, or your triglycerides, can enter the Krebs cycle. And your amino acids from protein breakdown can enter the mitochondria, all of which have the ability of producing ATP. You breathe in oxygen, we give out CO2. Okay? Okay, if you have muscle fatigue, that's the inability to maintain contraction after long activity, that can happen from inadequate release of calcium from the sarcoplasmic reticulum. It can happen from a depletion of creatine phosphate, depletion of oxygen or the vital nutrients. It can happen from a buildup of lactic acid and ADP, or you just don't have enough acetylcholine at the neuromuscular junction. So all of these things can create a degree of muscle fatigue. Now let's finish up with muscle fibers. Muscle fibers. We have different types of fibers. We have fast twitch fibers and we have slow twitch fibers. These slow twitch fibers are also known as red fibers. Let's see if I can bring this up here. These are red fibers, whereas the fast twitch fibers, these are white fibers. They don't have lots of blood. They have few mitochondria. So if we have few mitochondria, we think we don't have too much ATP. If you don't have too much ATP, then what's going to happen? You're going to fatigue quickly. You can have a strong contraction. You're going to have a fast contraction. Fast fibers are really good for power lifters, whereas slow twitch fibers, these are slow to fatigue because you have lots of mitochondria. We have lots of oxygen. We have lots of myoglobin or blood in the muscle. So because you have lots of that blood, it gives it a red pigment. So we call these red fibers. So when you look at meat, some meat is dark and some meat is white, right? You have white meat and dark meat. You ever have that conversation at Thanksgiving dinner, right? The white meat, this is found in the chicken breast, whereas the dark meat, the red muscle, is found in the chicken legs. Why? Chicken legs are dark because they have more myoglobin. Chickens are walking around with their chicken legs. They're not flying around in the air using their wings, so the chicken breast is white, less myoglobin, less blood, less mitochondria. So most of the nutrition is in the dark meat here, okay? So your postural muscles here, like your calf that keeps you standing all day, they don't fatigue easily. These are your slow fibers. These are fatigue resistant. But we all know that if you read Your eyes can get tired quickly. These muscles fatigue faster. Or your white twitch fibers. Okay, you have dark meat and white meat. So your white fibers, these are for power and speed. They're for short duration. They fatigue easily. Your red fibers are your slow fibers. They have lots of myoglobin, lots of mitochondria. These are great for endurance. Your marathon runners, your postural muscles are all red fibers. You heard me earlier talk about muscle hypertrophy and muscle atrophy. Hypertrophy is the increase in muscle diameter and the number of muscles and their thickness, whereas atrophy is when there's wasting away, there's reduced muscle size, tone, and power of muscle. We see muscle atrophy in people as they get a little bit older. Between the ages of 30 and 50, about 10% of the muscle tissue is replaced by fibrous connective tissue and fat. And between the ages of 50 and 80 years of age, another 40% of muscle tissue is replaced. So what are the consequences of this? You get muscle strength and flexibility starts to decrease. A person's reflexes start to slow down, and they have slow oxidative fiber numbers start to increase. So everything starts to kind of shut down and decrease in function. When I do my physical exam on my patients, I start with a handshake. I take their hand, I turn it over, and the first thing I do is I look at the back of the hand as well as the fingernails, and I look for hills and valleys. When I see hills and valleys like I do here, there's atrophy or wasting away of the muscles in the hand. This is either because this person who's older is not consuming enough protein, or the person is consuming enough protein, but they lack the digestive enzymes to break down the protein to get amino acids. And this is typically what happens as people get older. They don't eat as much because their digestive enzymes start to break down a little bit. So supplementing with a good, healthy digestive enzyme can help them break down their protein, so protein becomes amino acids, and the person can build up their body tissues again. Okay, so this is called sarcopenia. Remember the sarcomere? Sarcopenia is muscle wasting. These are the metacarpals. These are the extensor digitorum tendons. And in between, there's also muscles that should be thick, but they're wasted away. So one of the things I do in my office is called a dynamometer. A dynamometer checks their hand strength. They squeeze it, and I can actually look through a meter how many pounds of force the person has. Decrease muscle tone and tension in the body, and atrophy of muscles is never a good thing as a person gets older, especially not just in the hands, but in their legs, their quads, their hamstrings. This is why people, as they get older, have poor balance. Their balance becomes diminished. And keeping someone fully independent as they get older is so critical. One of the things I do besides the handshake in my office with my physical exams is I watch them get up from a seat. If they have to push up on the armrests, I know they have weak lower extremity. If they spring up quickly, and then I have them walk to the end of the hall and turn around, and they do that efficiently without losing their balance, that's not the patient I'm concerned about. But it's the person that stops and they slowly shuffle their feet to turn around in a circle because they can't do it quickly because they get dizzy or lightheaded, or their balance is poor due to weak muscle strength in their lower extremities. So muscles are really important. People, they need to sit and stand up, sit and stand up. And that is one of the best exercises anyone that's older can do, because if they can sit and stand up, that is called a squat. If they can sit and stand up, they can get on and off a toilet by their own. Very, very important to do. Hope you enjoyed this lecture on muscle physiology.